So a little while ago, we were lucky enough to have our good friend Simon Gawesworth give an awesome presentation on everything fly lines for us. And we're going to break this up into a couple parts, just so it's a little easier to digest. And the first part is just going to be about how a fly line is made. So we're going to get right into that, and here's Simon.
And what we're going to start off with is just really some very basic physics, chemistry, some really simple chemistry, what a fly line is made of. And very simply, a fly line has two components. There's a core, which runs right up the center, and there's a coating. And I can already see that there's some of the words are hidden here, so we'll just run by it. The core, okay, so the core is a very interesting thing. Right? This is a core material I've got here. You probably can't see it too well. I'll kind of hold it up. This is a braid multi-filament core. You can see it's kind of supple, right? So if you want a really soft, supple type of fly line, you want a core material that's supple like this, okay? Another type of core material is going to be a monocore. Look how wiry this thing is. So this is a much more of a wiry material. So a stiffer fly line is going to be made on this type of core. And that's good and bad, right? There's some disciplines in fly casting and fly fishing that want a stiff line, and there's some things that want a supple or soft fly line. So the cores are really the starting point. One thing that's pretty obvious if I compare these side by side is one is white and one is clear, right? As monofills are, this is clear. So right from the get-go, if you want a fly line that's going to be a clear fly line, you have to have a clear core, right? You can't have a white core because you're not going to get a clear fly line. So let's say we're sitting down and somebody says, "Oh, you know what? We need a clear fly line for catching guppies up in the Hebrides." And I go, "Oh, that's a huge market for that." So off we go. We're going to go design exactly that. Well, the very first thing is going to have a clear core, and that's what a monocore is. So sometimes you can't get away from a stiffer core, right? There's freshwater lines that are stiffer. Generally speaking, a stiff core, a coilier, stiffer core, are used in the tropics, right? In tropical conditions, because in tropical conditions you have the heat to make them relax. You tend not to use this kind of fly line in cold water because it is more wiry. But what if you want a clear line for cold water? You've got to have this clear core. So sometimes you just got to have that balance. You've got to have the clear line, so you're just going to have that slightly stiffer core. And so really that's how your cores are. Your cores are basically made of either braids or single strands of monofilaments or multifilaments. They vary in strength, right? So the weakest core material we make is 12 pound. You can see it there in our single strand monofilament. And that's a really light core. And I know that some people get worried about, ooh, you know, I don't want a line that's 12 pound in strength. I'd like something a bit stiffer, a bit stronger. Well, a Czech nymphing line, a Euro nymphing line, for example. I'll get one. I've got one hanging right here. These lines are so thin that guess what? You have to have with the core. You've got to have a thin core. I mean, look how thin this little line is, right? It's so thin. You can't build that on a thick core. So the thin, really lightweight line, something like this. This actually is our Euro nymph shorty, but it's something like that. That's got to be a very thin fly line. Will be on the weaker cores because, of course, it's got to be on a thinner core to make it a thin fly line. So generally speaking, your thinnest cores are, say, 12 pound, and those are your specialty lines, like that Czech nymphing line, something like a 000 fly line, a 00 line, that'll be about 12 pound. Once you get to about a one weight, almost every fly line is going to start off at the lightest with a 15 pound core. And that's the strength of the core, obviously at breakage if you pull it till it snaps. And then some of the saltwater lines, they get up super heavy. So we have a series of lines called the Leviathan and the GTs, and those lines are lines that require very strong cores for the disciplines that they're used for. And so the strongest core we use is the 72 pound strength core. So your fly lines are going to kind of be based on those kind of strengths, somewhere in between, right, depending on the size. And we take all that into account in the design when we sit down to design a line. And then some of you may know about the connect core and the direct core. Connect core and direct core are just our lower stretch core materials. You can kind of see the stretch facility there, or the stretch numbers in that. To me, for a performance line, I like a low stretch line because I'm in control. Right? When I start to move my fly rod, I'm starting to move the fly and the leader immediately. I'm not bunging and stretching the line. When I'm playing a tarpon or a big salmon or something, when I turn and put 5 pound of force from my rod hand in, I'm putting 5 pounds of force on the fish, not having a stretchy line. So I like low stretch line, but not everybody does. There's some people do like the spongy effect in the fly line, and so we make them both, right? So you have those options. So the core is a numerous materials and numerous diameters of materials, numerous strengths of materials, numerous strengths of materials. But one thing I want to touch on very quickly is twist and memory. And the twist and memory is an interesting thing. So what I have here, again, hopefully you can kind of see this in the background of my gray shirt, maybe not. But here I have a coily line. Can you see some kind of wave in it? I can kind of just about see that. So this is a saltwater tropical line in our beautiful Washington weather. It's raining, it's about 51 degrees, it's not tropical out here. And so in these cooler conditions, this line is much stiffer. And guess why? Because it's built on this monocore. Right? You can see what the monocore does on its own, therefore the fly line is going to have a very similar trait. That is called memory, right? All that is just remembering the shape when it was coiled onto a reel. Memory is a very, very simple thing to sort out. Right? If you ever pull a fly line off a reel and you find your line has these coils in there, if you do nothing about it, you'll make a cast and 10 or 5, 20 casts into your session, suddenly all your line will jam up and get caught in the butt ring. Right? That happens. I can see everyone's been nodding away because it happens to everybody. It happens to all of us, and whatever you do, it still happens. And generally speaking, it's because these coils, these kinks in these coils, catch up with a previous coil and they come up and jam because the shoot happens so fast. Memory, you should never worry about. Right? If you have a line with memory, the fix is very, very simple. You can see I just I'm taking a couple of foot stretch section here. I give about a 2 pound pull, and you can see you pull the memory completely out. Right? So that is now beautiful, straight. And I get to the point where I didn't stretch it. You can see the coily bit at the bottom here where I didn't stretch it. That's where I held it. So when you stretch it, you get rid of the memory. So stretch your lines, right? If you're using a stiffer line and you're having those casting problems and the lines are jamming up on the rod rings, it does need a stretch. It needs a little bit of maintenance. But what you want to recognize as a difference is something called twist. And twist, again, hopefully you can see, again, I'm looking for Anthony's thumbs up. Can you kind of see a loop there, Anthony? All right, so if I take about a 3 foot section and put my hands together, you can see that that stays in that U shape. This line has no twist. So I'm going to fake twist right now, put it in with I'm spinning my fingers. And you can see now if I do that same U, see how the line just spins up. That's twist, right? That's a completely different memory. A lot of people get mixed up. They get twist and memory mixed up. They cast, the line jams in the butt ring, they say, oh, I've got memory. And people get frustrated, they send their lines back to Rio, and you frequently find these lines with all this twist stuff in there. And twist, very simply, you just get twist out by you just pull it through your hands, or you walk it down to some grass, or you let it hang in the river, and you just walk it out, and you can see you get rid of your twist. Don't ever send the line back to Rio that's twisty, right? Because we'll untwist it for you, but we're not going to replace it. Twist is not a warranty issue. Memory's not a warranty issue, right? The line's designed to be stiff to do something, so stretch it out. So that's what the core does, right? It's got a little use there of core, a little kind of reasoning behind the types of core materials we use, and the end result those cores produce in the fly line. Let's take a little look at, let's skip past that one because I'm talking too long already. Let's take a quick look at some of the coating materials, right? And the coating materials is the secret chemistry that every fly line company has. There's base ingredients. Your base ingredient is called a liquid plastisol. And it tells me right there, that's what this is. You can't see it, but it's a very thick liquid plastic. And quite simply, if I was to pour that into, you know, those little foil cookie trays that you can make cookies in, you pour that into a little foil cookie tray and you throw that in the oven and you bake it at 350 degrees for 7 minutes, whatever the heck it is. Out will come a clear, slow sinking piece of plastic. That is the natural state of what is called liquid plastisol. Now, we don't want every fly line to be slow sinking and clear. So when you don't want a slow sinking line, you want a line to float, you have to do something. You have to make something, add something to make it float. And that is what's called a microsphere. You can kind of just see my vial. You can see at the top there that these are just tiny little, individual little glass spheres that are hollow, full of air. And we pour some of that into the liquid plastisol, and that will turn the fly line from a slow sinking line to a floating line. And of course, the more of those microspheres you add, the higher the line floats. Sounds great. There's a problem. There's got to be a balance, like all these things. And if we want the line to sink, well, then we put in some of this stuff here. You can't see it because there's not a lot in there. This is powdered tungsten. Right? That will make a line sink. And the reason there's so little in there is not because we're cheap. Oh, I'm cheap and half Scottish. It's because when I do these talks at clubs, what I want to do is I pass these vials around, and these two amounts weigh exactly the same. So if I wanted to, let's say this weighs an ounce. It doesn't, but let's just call it a number. Let's say I wanted to make a fly line weigh an ounce, and I pour in an ounce of this, and I pour in an ounce of this. Look, what is the difference in volume going to be? Right? This is going to have a far more voluminous than this thing, but it still weighs the same. So the stuff you put in all influences the final weight of your fly line. And if you want it to float, we'll put more of these in. And if you want it to sink, we'll put more of this in. And the faster you want it to sink, the more of this you put in. Okay, so those are your ingredients that change the density, floating or sinking density. And there's a point in the mix where it'd be like taking a cup, right, a coffee cup, and filling it to the brim, and then putting a teaspoon of sugar in. Right? At some stage, then you put another teaspoon of sugar in, that will overflow. And at some stage, as you stir it and you keep adding sugar and all the liquids overflowing, you having less liquid and more sugar. And you get to a point where you can hardly stir it because there's so much sugar in your coffee. And that's the point a fly line can reach, right? If we think we want to make something float super, super high, and we put a pile of this in, well, if we put too much of this, we lose the liquid, which is the plastisol for the size of the container, right? Our coffee cup, which is the fly line diameter that we actually want, the size. And so you can't make a fly line, right? Because there's no plastisol to bond it. The fly lines crack, they break, they have no lifespan to them. So there's a juggling act between how much buoyancy we can get in the fly line by adding microspheres and how much sinking speed we can get by adding the tungsten. And then, of course, on top of that, as you can see from this list, there's some silicons and color. If we want a purple fly line, we're going to put purple coloring in it. Right? So there's all these ingredients. And that is your coating mix. And it's basically, it's stirred up into a thick soup, and then it's applied to the core. We're going to skip durometer for a second just because I'm talking. And I'm the headmaster, or whatever. What do they call the headmasters over here? Principal. So you got to listen to me. So how a fly line is made, well, that's the ingredients. Now we take the two ingredients, and this is going to be really, really awful because my drawing skills are just disastrous. So just live with it. Kind of bear with me. So what we have here is a very, very crude picture of how our fly line is made. There's a long, thin black line coming from the left screen into an O, and a blue line coming out of the O to the right. All right. Can you all see that? Does that make sense to you? All right. And then there's a blue dribbly line coming down from the top, and then underneath the O, there's blobs. That's a fly line. That's how fly line's made. So the left-hand side, the black thin line, is basically our core material, just as core. And it's moving along the machine, and it reaches this O. And it goes through this O, and just before it goes through this O, I don't know if you can kind of see, it might be better with this. So it goes through this O here like that. And then just before it goes through this O, on is deposited that liquid soup we just showed you, the floating compound, the purple fly line, the sinking, whatever it is. And then this O here, this orifice, is what it's called, that shrinks in size to the diameter we want the fly line. And quite simply, the line is pulled through this O. Kind of hard to show you that. Maybe I'll turn it this way. And is scraped to the diameter that's required. Complicated stuff. To give you some numbers, just because a double taper 5 is a very simple line to remember. If you have a basic floating double taper 5, the body diameter, that part of the fly line, right, of the double taper, this diameter here will be 50 thousandths of an inch. That's easy to remember, it's a 5. And then when you go to the front end of a double taper 5, you go to the thin tip, the thinnest taper, the front end of that is 36 thousandths, that's a 14 thousandths difference. Let's call, for the sake of simplicity, we're going to make a 10-foot long taper. Okay, so this orifice thing, a fly line is made in the oven and it runs at 10 feet a minute. Okay, 10 feet a minute. If we want a taper that's 10 foot long, our computer will tell the machine to take exactly 1 minute to shrink from 50 thousandths to 36 thousandths, scraping the line to the diameter. And that's how a taper is made. Does that make sense? So that's how a taper is created. It's always created in the plastic. And when you want the line to go fat again, right, the iris, the orifice, whatever you want to call it, opens up to the diameter. So a fly line is basically scraped to the diameter. And in this picture you're looking at here, the other side of that O, that orifice, the blue side, is an oven. And the heat instantly seals it and basically seals the outside to stop it falling off. And then it runs through an oven at this speed of 10 feet a minute. And let's say it takes 5 minutes to cure a fly line, right? Then it's judged. A fly line cures at a different rate, right? You might get a fly line that's as fat as that. That's going to take a lot longer time to cure than our urine nymph line. Look at the diameter difference in these two, right? You can see that. So this one being thin will cure far quicker than that. So we have to adjust the time and the temperatures. There's all this lovely stuff that goes into it. But in a nutshell, this is how your fly line tapers are made in most fly lines, right? Most fly lines are made of PVC, and they're made of PVC. It's a liquid plastisol. All the line companies that make lines out of PVC create their tapers with this variable orifice scraping system. The only other way you can create a taper, and you can't do it with a PVC style fly lines, is all about temperatures of melting points and stuff like that, is through horizontal extrusion. And the simplest way to describe that is, imagine that something's being pulled along a train, right? A train is just zooming along at a certain speed, and behind it lots of water droplets pouring off this train. Well, as that train accelerates, the water droplets will nip down to a thinner diameter. And so that horizontal extrusion tapers are controlled by the speed of acceleration. So when you want a thin fly line, the line is pulled really fast, and that gives a very, very thin fly line around the core. And when you want a thicker fly line, the line is pulled a bit slower, and you can create a fatter fly line. When you want to create a taper, the line speed accelerates. That's called horizontal extrusion. And there are fly line companies that make horizontally extruded fly lines out there. These are the two ways that they're made. And there's advantages with both, right? There's advantage with horizontal extrusion in that the plastics that are being used are much more sophisticated. The downside is that you can't control tapers. You can imagine that acceleration thing. How accurate can you be with a taper? Right? With this orifice thing, you can make 10,000 changes in an inch if you wanted to. Much, much more sophisticated taper systems with this. And also it allows you to do this. This is a 2-color fly line or a sink tip. Imagine the blue stuff's floating and the red stuff sinking. So if we want to make a sink tip, the hopper of blue stuff, the floating stuff, opens the valve and deposits it onto the moving core this way. And then when it's time to make the sink tip, basically it closes the floating and opens the sinking valve, and the sinking stuff is deposited and moves on the same way. So you can make fairly short changes in diameter or in density or in color with this system. And that's vertical extrusion. That's how most fly lines are made. And a fly line is made in this giant rope. It's called a skein. Skein is about 1,500 feet long. It's about the shortest skein it is. It's a rope of fly lines back to back to back. And when a fly line's made and set on these drying racks and cured and ready to coil, they go to the coiling station, which you can see here. Anna's just coiling this. And and she's got one of these little foot pedals that she pushes down with her toes. And you can kind of see that blurry wheel in the middle that's spinning around, and she's weaving the fly line back and forth between those two blurry plates. And that's how you get your fly line coil, right? That's what she's creating here with this coil, weaving it back and forth with these plates and building it up. And then when she gets to a point, before that, when she gets to a point where it's finished, the fly line ends. Between each fly line, we build a bump. Again, I don't know if you can see this, but it's pretty thin here. We build a fat lump here, and then gets back to the thin. So when she feels that fat bump, she knows that you cut that off. That's the end of that fly line. Cut it off at the other end and start the next fly line. So that's how she knows in this 1,500 feet of fly line where the next fly line begins. So if it's a 100-foot fly line, we're going to get 15 fly lines out of that coil. If it's a 10-foot tip, you're going to get 150-foot tips out of that coil. But they're just made on these endless ropes. And then what she's got there, she's got some orange labels on by her left hand. Those are fault labels, right? So if she feels a bump in the fly line or a floor or anything, any texture, anything at all, she's going to take one of those orange labels and put it on. And if it seems to be, and she puts those cores aside, if there seems to be 2 or 3 fly lines with a bump in the same place, then it goes over to our QC guys and they check it out, our R&D team check it out, see if there's a fault in the machine or a computer program that's put this bump accidentally in there. Usually the bumps are caused because this braided core that we have here, sometimes there's just a little hair, that's just poking out. You know what braids like, everyone knows, like sweaters and things like that. You can get a little fluffy bit poking out. And of course, if you coat that in fly line, you get a bump. And she feels that. And if it's as simple as something like that, then she just chops it up, throws it away. Or actually sends it over to Montana, where we turn all those lines into these fly line bracelet things. So that's your line is made, and then it goes to a welding station, right? And the loops get welded in, and then it goes to the boxing station and packaged and boxed and off to your wonderful fly shop to be fished. That is, in a nutshell, how a line's made.